Hello, guys. Glad to see all of you here. First of all, make sure that you scan this QR code. So I will be checking all of the questions after this talk at Slida, and we will. There's going to be a giveaway for the most interesting questions that reached the highest number of likes. So please make sure that you ask your questions there. Don't be shy. Use any language you prefer. At least I know 3 languages. And give us some thumbs up to the other questions. Okay. So let's start. So today we are going to be talking about technology agnostic microservices at single page application frontend, and all of the challenges that you may face with during this journey, and why would you need it, and so on. So moving forward. So should I listen to this talk, or should I check Instagram or Facebook like we all like to do, right? So if you're not gonna check it, you will find out what are the microservices at the front end. You'll find out what are the possible approaches, what are the pros and cons of each of them. We are gonna look at the real world working solution overviews that you can also check at GitHub after this talk. And we'll also check what we currently have in my company in production, and all the other tips and bells and whistles that may be helpful for you. So moving forward, a few words about me. So I work at Namecheap at the position of the director of R&D. This talk, it's kind of a result of my work during last couple of months. So I'm working with JavaScript for quite a lot since the MooTools era. Is there anyone in the room who remember MooTools and use MooTools? Well, that's really great, guys. Really appreciate it. So yeah, about the company itself. So we are providing services, the variety of services that you might need to build your own presence in the internet, and we have an aim. We believe that it's important to open the door for everyone to a free and open internet. So by saying opening the door, we are literally opening the door by our customer support and services that enable our customers. And by saying free and open internet, it means that we believe in freedom that you should have in the internet. And we believe in an open internet, in unrestricted internet. And we actively support various foundations to move this goal forward. Okay, but let's get back to our main topic. So do we really have an issue? What else? Why should I need something? Why should I know something about microservices at the front end? So what are the microservices? So we all know microservices. Who of you guys really use microservices in production? Backend, any microservices? Okay, not many of you. Who wants to use microservices? Okay, that's better. So in a classical description of the microservices, so they allow us to build highly maintainable, loosely coupled applications that allow independent deployment, that allow to scale company to many teams, and achieve that scalability without going through all of the mess of the synchronization of the deployments, through all the challenges that you face with when you work on a single code base from multiple teams and so on, right? And here is the classical image of the microservices architecture. So here we have an API gateway, we have our storefront web app, we have some backend microservices. This is the authentic, I would say, description of the architecture, right? So do you have an idea what are the issue here? What we are missing here? Who can tell me what we are missing here in this picture? Front end? Who said front end? So yeah, we here, like, instead of front end, we have only this storefront web app, right? And it's just a single box. And this is how usually people represent front end in their architectural drawings. But like, this is like not the truth, right? Usually front end, it's more complex thing. And as a result of drawing front end as a one box on the architectural diagram, we usually have something like that. We have a lot of well-defined microservices on the back end that like loosely coupled, well-defined, well-architectured. But on the front end, we have this one single box, right? And different teams contribute to that box, maybe through their own components. Maybe we have some guidelines there, but it's essentially just a box, right? So can we do something with it? Can we improve our experience? So in reality, like, we can. There is a micro frontends concept that aims to break that single box onto multiple ones, right? And allow teams to work on their features from end to end, right? So they would be able to work not only on the backend side of their features, but also on the front end, fully independently, right? So this is the main goal, to allow cross-functional independent teams to create functionality starting from the backend and finishing at the front end without a lot of touch points with the other teams or with infrastructure or like with some coordination team. Let's see how it works, right?
Picture your single-page application. It's written with an old framework, and it keeps getting larger. Your team is stepping on each other's toes, and deployments are getting harder and harder. You want to use a newer framework, but the impending rewrite dominates your shower thoughts. Now imagine converting your app into microservices. You split things into self-contained applications. Your team builds and deploys the application separately. That new JavaScript framework you've always wanted to use it. And don't worry, you can change it later if you want to. You'll never have to rewrite the entire project just to use the latest and greatest.
So what we are achieving here, right? So first of all, this video, I kind of stole it from a single SPA project. This is just a part of what they have. And it represents an example when we already have an old application. But this is not the only use case that we may actually have. So the other use case would be we already have multiple teams and we want to coordinate their work in a better way. So what we are achieving by introducing micro frontends, right? So we would have independent deploys. We would not have to decide in advance which framework our like the whole company or like the whole group of teams would use for the next 5 or like 6 or indefinite years. We can change this as we go, and we can like really make teams independent. So instead of having big monolith on the front end, we would have something like that. So we would have this pretty the same architecture as we have on the back end, but we would all move it to the front end, and as we work, for example, on the login microservice, we can also handle not only the backend functionality of the login flow, but also the front-end part of it, which makes team truly cross-functional. But do I need micro frontends in my project? Remember, I told you about like several use cases. So for me personally, I kind of picked those two. So the first use case where you might need micro frontends is if you have several cross-functional teams. And the second use case, if you are working on an old application and want to start slowly to modernize it, by moving to a different framework or like new or to the like 2 or 3 modern frameworks if you like again have those like concept of cross-functional teams. And again, bring your own case if you have. I'm sure that there are more cases. For example, in the previous day we had a talk about like the dashboard and like how we can create a dashboard and all of the other teams to contribute to the dashboard, right? It's pretty similar to the several cross-functional team, but just in a different manner, right? So we have some functionality that handles not only like the business logic that a single team owns, but also like embeds pieces of business logic that other teams produce. Moving forward, remember in this picture, we have this scene UI layer composing microservices together, right? So if this is very similar to the orchestrating layer we have for backend microservices. So for backend, we may have service discovery, we may have, what else? We may have some kind of Docker orchestrator, we may have some authentication services and so on. So some system services that allows us to build those backend microservices effectively. So for the front end, we need to have something like that. And the main functionality of this layer, like system layer, would be page composition. So let's talk a bit about what are the page composition. So what is the page composition, right? So basically, we have a page that consists from the microservices, and when I go from one URL to another, I need to change the set of the microservices on a page, right? Let's check it again. So we had a home page, we have 3 microservices here. Now we have like a different layout, and again, now we have two other microservices. But for example, the header remains the same. So we don't want to reload it, or we don't want to reload it. So let's look at this pretty similar example, but from a different standpoint. So we have fragments, and so in this example we have header, we have sidebar, we have content part, and here we have a layout, right? So those are the essential parts that we need to perform page composition. We need layout, we need some slots defined in that layout, and we need the content for that layout itself. So during the composition, the system takes this information and composes the page and sends it to the client or shows it to the client. This first composition may happen at the server side, or it may happen at the client side. Usually it happens at the client side because it's just easier. But if you really take care about SEO, you may need to have it at the server side, because it would work faster and you wouldn't have any issues with the bots that cannot execute JavaScript and properly render the page that composes only at the client side, right? And after that, like moving forward, so we compose the page, and the customer wants to go to a different section of our website. So what happens is that we need to perform a recomposition. So in this example, composition, again, it may happen rather at the server side or client side. So we have a change of state for the set of the micro frontends presented on the page. So for example, what happened here? So for this micro frontend, it changed its state, right? So like in previous slide, the home button was highlighted. In this example, subscriptions are highlighted. And here we have completely different microservice loaded. So before that, we were showing recommended application. Let's imagine that this is like 2 different apps. And in this example, we are showing today's videos, right? So we unloaded the previous app and loaded like this today's section. So what are the options we have to handle this composition and recomposition? So generally, I would like highlight the following ones. So we may rather use one framework and break our code onto NPM modules. They can be statically or lazily loaded, and again, they can be like built together with our composing layer, or they can build separately. But generally, the idea is that we are using single framework, and we are relying on the router that is like provided by that framework, and like many other features. Or we may choose a different route and support multiple frameworks at the same time. But in this case, we need to create kind of our own framework that would handle, again, routing, that would handle loading and unloading of our micro frontends, and so on. And we can perform composition on a page rather at the server side, at the client side, or at the server and client side at the same time, depending on the context of the execution. So, and we have an issue. Okay, so let's look closely at those approaches. So if we would choose the first approach of one framework, we would sacrifice technology agnostic principle, and it may work well for like for some companies or some projects if you don't have like tens of teams that are working all together on some functionality, or if it's functionality not as big as, for example, our ones. If you're not planning to support that functionality for years and years and evolve it as we go. Because frameworks appear and disappear, and I would suppose that business doesn't want to be in a case when, for example, I don't know, let's imagine that React was deprecated and now we need to rewrite our code to some new framework. Or for example, like it was with Knockout, for example, or Angular 1. So this is the first approach. The second approach is that we may support different frameworks, but handle composition only at the client side. In this case, we are sacrificing SEO and social media bots compatibility. And the UX level would be limited because we need to load all the information at the client side, execute the JavaScript, after that go to the server and request all the data, and only after that page be fully rendered. So we would have higher initial load time for our website, which may not be acceptable. The next point would be server-side composition. This is something that we currently use at Namecheap. So how it works is that we, as customer requests the page, we compose all the microservices at the client side, and we perform server-side rendering for those microservices. And as soon as page will be loaded into the browser, those frameworks will be loaded. And if customer doesn't leave the boundaries of those framework, every transition will happen at the client side. But if customer wants to go to a different section on the website, we need to reload the page again, go to the server, recompose the page, and present different set of the microservices. And the last point would be isomorphic composition. This is the case when we are performing composition first time on the server, and all the subsequent URL changes, it will be performed at the client side. So let's look what we currently have in production. For this, I will go to our website. So this is our production, nothing special. So what we have here. So here we have actually two micro frontends. Let me show them to you. So the first micro frontend, let me make it bigger. So the first micro frontend here, it's a header. Let me show it to you. Where is it? Oh, here it is. So it's header component, And if you can see, we have React root attribute here, so it means that it was rendered by React. And the body part of the page, it's actually rendered by Angular 1. So we have Angular 1 here at the page, and we have React at the header. And we can prove it by, how can we prove it? We can prove it by looking at those attributes. So we have ng-csp and UI view attributes. So this means that we are using, as far as I remember, UI router here for Angular 1 and CSP policy. Right. And if we would go into the source code of the page, we would see the following, that for the header, let me show you header. Here is the header. Let me make it bigger. So for the header, we have like server-side rendering performed at a, during the page composition, but for the body part of the page, we only render the other shell of the application, and like we don't have any server-side rendering here. So this is kind of a mixed approach, and let me show you how it works. So if I am navigating within this section of the website, so for example, I would go to this page, to this page. As you can see, there is no page reload. So everything happens smoothly, like header remains as is, like no full page reload happened. But if I would go to the main page, to the different section, we need to reload the page and recompose the set of the microservices presented. So like to and from the different section, we have page reload. Within the website section, we don't have any page reloads. Moving forward. What are we going to do with this? So we have our next generation solution called Isomorphic Layout Composer. You can check it at GitHub. And let me show you how it works. So it's currently at the POC stage, but you can already check it and see if it's going to be useful for you. So what we have here we have an application, like a website, where we have a header again at React, and we have, for example, planet section that was created at Vue.js. And here we have a people section that is created at React. So for the header, we have server-side rendering. For those two applications, we don't have server-side rendering. So, and let me show you how it works. So here is the header. Here is the header. Here is the navbar, and it was server-side rendered. For the root planets, we can see that planets, they were highlighted. If I would go to the people now will be highlighted. So we have server-side rendering. So in previous generation of the system, we would be forced to perform page reload as I go from this section to this section, because we are actually unloading this microservice that renders the body part of the page, and load another one, right? So when I'm going from people to planets, I need to unload people microfrontend and load planets microfrontend. So, and this happens at the client side. Let me also show you how it's possible to add a new microservice to this setup. So to do so, I need to go to our registry. Let me turn on presentation mode. So I need to go to the registry. So first of all, I would add news menu item. So I added news SSR, but it still returns 404 not found, right? To fix it, I would need to, where is, oh, just a sec. I would need to go to the registry and add an information about new microservice. So what I'm doing here, so I am inserting new record. I'm doing this through the SQL just because I was too lazy to create an API for this because it's only a POC, right? So what's happening here? I'm inserting new application to the registry. So it would be named portal news. So what actually happens here? So I have SPA bundle. This SPA bundle is just a simple JavaScript bundle that you would normally have for your application, right? Just JavaScript that we need to make our application work. After that, I have CSS bundles that is required for this app. And here is the most important part. Here, I'm saying that I also have SSR capabilities, and I am exposing SSR endpoints. So when if I would go to that SSR endpoint, I would see the source code, the SSR rendered content for this application, right? So I have like all my news here, but of course they are not operable because they need like the whole composing layer present on a page. But and the last but not least point, I have also here assets discovery endpoint that tells where like the assets can be found. So if I redeploy my application, I don't need to go to the registry every time during every deployment and change those values. So I added the application to the registry. After that, I am adding new route. And I am saying that in this route, I will have portal news rendered at the body slot. And let's try to refresh the page. Oops, sorry. Yeah, so now I have news rendered on a page. So now we have 3 microservices on a page. So we have people, we have planets, and we have news. And news, they are rendered on the server. And we can prove that by going to disable JavaScript. So if I would disable JavaScript, this application will continue to work because it was fully rendered at the server side. I can even navigate through it. But if I would go to this part of the website, like people and planets are not operable now. So, and let's turn JavaScript back. So, again, now in practice, let's look at the page composition and recomposition. When I'm refreshing this page, what happens? Browser sends request to the server. Server goes to every microservices it should render on a page, calls SSR endpoints. That SSR endpoint, results of those SSR endpoints would be composed onto a single layout, and that layout will be returned to the browser, and after that, framework hydration will happen. So if I would go to a different section of the website, I don't need to go to the server anymore. Recomposition on the page will happen directly in a browser. So like here, like there is no SSR, right? So when I'm like going from planets to news application works like if there is no SSR at all for news. Like like it doesn't support SSR at all. So moving forward, how it actually works. What are the technologies we used? So we used, looks like I have some issues with the connection. Let me try to, come on. Okay, let's do like this. So to make it work, we use two key technologies. We use Lambda Tailor, which is used to compose page at the server side. And we use single SPI. This is a JavaScript framework for micro frontends that handles client-side recomposition. If we would go deeper how it works in reality, we would see that the overall architecture is the following. So we have UI composition layers that works at the client side, and we have layout composer at the server side. In between them, we have isomorphic components of the system. So we have template engine that allows to handle template changes at the client and the server side. And we have router that works again on like server and client side. And we have registries that supplies information about what are the applications we have, like generally for the website, and in which and at which routes they should be rendered. And again, we have our microservices that may work at both client and server side, or they may work only at the client side. If we would look closely at the microservice itself, so it consists from the following parts. So we have our like app shared code, which handles business logic of our application. As usually, we have client side bundle and server side bundle. Client side bundle in its turn exposes mount and unmount endpoint, and not the endpoints, mount and unmount methods. So mount method will be called when the composition layer needs to load the application, and mount when it needs to unload it. So basically, like this is the whole interface that should be implemented by every microservice. And by making it so simple, we are allowing different frameworks to kind of get into the system. So it's like implementation of the adapter like takes literally like few hours. So all we need to do is to mount our application, and if it supports this, we can like add it to the system. Server-side bundle in its turn executed at the server instance of our microservice and expose server API. So that server API is responsible for handling asset discovery endpoint and responsible for handling server-side endpoint. So one of the challenges we had was to achieve code isolation. So this means that all the frameworks and all the applications that we run need to follow the following principles. So first of all, they shouldn't modify window. And the second point, they shouldn't perform any DOM modifications outside of their container, and except the cases when we agreed to do so. For example, we may have some shared element on a web page that will be used for models. The last point, this next point is there is no shared CSS. All CSS should be scoped, and no shared state. Every application has its own state and communicate with the others via events. So from our real experience and current system, we banned Angular, and because it was adding its instance to the window, and we banned Angular 2 because it was working bad when you have two instances of the Angular 2 on a page. So there were issues with an AOT compilation and Zone.js, but nowadays looks like it gets better in Angular 5 and 5+. So how page composition works? So for every root, we are saying that we would use like a template, and the template has the following structure. So it contains like the other shell of the page and the slots. So those slots will be used to determine in which place micro frontends should appear. So basically, it's very simple, right? I'm positioning a slot, for example, in a header, and I'm saying that, okay, header micro frontend should be here. Or I am like placing a body, and I'm saying that, okay, body will be here. The next component of the system is the registry. So registry contains three main sections. It handles applications, routes, and the templates. So templates is basically those templates that I shown here. Let's talk about apps and routes. So we are registering an app, right? Like this, the same structure as we did before with SQL queries. And we are registering a route. So in this example, what happened is that we registered a news. News uses template master. Here is the template master, and the template master contains the slots and determines where which micro frontend will appear. And like the values for the slots are here, so I can say that at news route, under the body slot, I need to render portal news application, right? So pretty simple. Moving forward, how routing works. So in this POC, we used two-tiered routing. So first level of routing happens at the page composition layer, and it's performed by these routes that I showed here. The second tier happens within the application itself. So how we are making this possible? So we are saying to every application that here is your base route, and you need to go from this point. So if your, for example, React application or Vue application already works with default router that manipulates the URL, all you need to do is just consume the base path that we are providing, and everything will work like as is, no changes necessary. I can even make a super short demo. So for example, we have people here, and let's, for example, pick air.deadba, and let's see what the details about its own homeworld, planet Naboo. So when I click here, I would go to a different application and we'll see the details of a planet. So basically, how it works. User clicks a link. An app framework invokes, in our case, it was people application. It invokes history push state, as every SPA application does nowadays. After that, our isomorphic layout composer listens for the hash change, push, pop state, and A click events, and intercepts them, checks if recomposition of the page necessary. If it is, it invokes unloading of the pages that are not going to be present on a new page, and loading of the micro frontends that are going to be present on a new page. It's pretty simple and works out of the box with like with every routers that you may have, because it uses browser API. As for the code loading, we use system.js. So basically, every micro frontend will be registered as system.js bundle, and it may even declare its own dependencies. So for example, if on a page we have multiple fragments that use React, because of the system.js, we can load React only once and share it between the microfrontends. So how to do this? All you need to do is to define externals section in your webpack config and say that, okay, React will be an external dependency, and compile your code as an AMD bundle. After that, like, magic happens because system.js is on a page. AMD bundle will be registered in a system.js, and all of the dependencies of the bundle will be resolved by the system.js. Moving forward, few more advanced things may be helpful. So how deploy and rollback happens. So we have two challenges here: how to notify isomorphic layout composer about new versions of the fragments or microfrontends, and how to synchronize versions of the code at the server and the client side. So for the first thing, how we are handling this. So we have basically two ways to notify our system about new version of the application, rather to make an API call and say that, okay, here are the values of the new JavaScript and CSS bundle, or use version discovery mechanism that I shown to you here. So how this mechanism works is that we say that please go and periodically check the following URL, and that URL should contain the following JSON. So for example, it can be an API on the server side of your application, or it can be just a file at the CDN, which you can update as you deploy your application. Just make sure that you don't have any caching for that file. And basically, this is how the deployment of new version happens. But we have an issue here. An issue here is that our layout composer may work in multiple instances, as well as our application. And we may have an issue when ILC, first instance of the ILC knows that app1 now in V2 version, and the second instance of the ILC knows that app1 now is in first version. And again, like, application itself also in progress of deployment. So different instances of the application, we have rolling deployment, for example, different instances of the application now work with different versions of the code. And like, the issue is the following: we cannot allow code produced, like server-side rendered by version 1 can be handled at the client side by code of the version 2, because we may have an issue there. So how we are handling this? We are adding a special header generated during SSR that says that this code was generated with this bundle, and the value of that header will override the settings in the registry. So by doing so, we'll always keep our SSR bundle and JavaScript bundle in sync during the application deployment. I can even show it to you if I would go to the SSR URL and would inspect the network. So I would see, let me show you the headers. So where is it? It's too much scaling. Yeah, so in response headers, there is an X-head method. Sorry, it's the wrong one. I still haven't added support of this header here. So basically, here we would have an, like, similarly to the X-header meta, we would have what is the name? X bundle overrides, which would say that here is a link to the JavaScript bundle that was used to generate this page, and here is a link to the CSS that was used there. Moving forward, error reporting, right? As we have applications from multiple teams on a single page, we need somehow to track errors and report them to our analytics system. So, but how can we distinguish which application thrown an error if it wasn't handled? So to handle this, we use two approaches. First, of course, the simplest one, use framework capabilities, but not all the errors can be caught by framework handlers. So to overcome this, we are making the following trick. So we are setting our own global error handler. And as we are getting information about an error, here we are taking the file name from which that error was thrown and asking system.js, please give me the module info by this file. So, and in this module info object, we would have the name of the system.js application. In our case, this would be like portal news or portal people or portal, etc. So in reality, it would work like this. So if I would go and generate an error here, I would have the following result. Let me make it a bit better. Some parser. So I would have fragment error, the name of the error, and the module name. So this error was thrown from the news application, right? Because we basically generated it from the news application. This is not a built-in system.js functionality. I mean this function. So like in default system.js setup, you cannot ask system.js, give me the information by the file name. This is an add-on that we've created. And again, you can check this add-on at the GitHub. It may be useful even for other needs. So how cross-fragment communication works? So as I said previously, we mainly use events. And like as for now, we believe that this is the most optimal scenario because it supports loose coupled architecture. But there is another way out. You may use shared services. So for example, in the example here, we have application people and application planets. But those two applications, they actually rely on a third service called fetch with cache. So every interaction with an API they perform via common dependency that was again loaded only once and shares basically an information between those two applications. So theoretically, you can also create your own services that would kind of handle the communication between different applications, and by doing so, you can implement more complex scenarios where events capabilities are just not enough for you. And again, you can use shared state, but currently we don't recommend this because it may be too complex to handle at large scale. What are the further improvements? So since this project is in the POC state, we have quite a long of the improvements list. So we plan to integrate, to have a better integration with Tailor and single SPA projects. We aim to support better template transition. So currently there is, like, if you would go from the route that uses template A to the route that uses template B, application would just throw an error, or in a better case would just reload the page. So we want to build in template transitions that would allow to not only change the set of the microservices on a page, but change even the structure on the page without its reload. After that, like again, local development environments improvements, tests, a lot of documentation, built-in monitoring, and so on. And just want to remind you that this is all in open source, so you can check it out at GitHub. So thank you for listening. That's all from my side. And let's check if we have a questions here. Yes, and we have a questions here, and let's start from the top. So EL asks how to solve an issues with memory leaks. For example, when one sub-application will add some even listeners and be deployed without removing these listeners. Okay, so this is an interesting question. So there is no easy answer here. So you literally need to pay attention. I tried to experiment with some kind of the watchdogs that would like track all the unauthorized changes to the DOM, to the window. I would track all the even listeners, but like I haven't succeeded there yet. So the only recommendation would be perform code review and educate your teams that this is something that is like not very desirable. Okay, like the next question, like if you're a front-end guy. Not sure what does it mean. Okay, looks like it's not a question. Okay, the next one. What about client application here? Client application size, it looks like we should load multiple bundles with different framework instances. So as I said, because we are using System.js here, we can load framework code just only once and share it between different fragments. There is no big deal here. Just declare your framework as an external dependency in Webpack configuration. And the next one, orchestrating by different frameworks looks like quite complex approach. What should be general implementation of orchestration layer to deal with that? So basically, the general implementation of the orchestration is like here. It's in the GitHub. Please go and check it out. If this anonymous user is here in the room, maybe you can clarify this question. So, and looks like we don't have this person here. So what about routing conflicts for different microservices? So that's a good question. So currently we are not directly like technically solving for this. So the solution is that the main router is like it's a single entity, and all the changes to that entity, like changes of the configuration, should be like validated by some central team, I assume. So we are not going to have duplicates there. But you may have duplicates in internal routes of your applications. And this is solved by passing the base URL to every app. So if, for example, app is located at the /news/URL and has its own subroutes, so it would be aware only about subroutes and wouldn't handle the base path itself. So the next question is, how about the performance? So like the answer is pretty similar to the client size application, to the client application size. So first of all, you don't need to load every framework multiple times, but of course you would have a performance penalty just because you would have multiple instances of the framework on a page. And I would propose to finish at this question. I will answer to all the other questions in the app, so go and check the app itself. And I wanted to ask if we have EL in the room. It's you, okay. So I have a gift for you. So this cool Namecheap branded power bank. Thank you for such an interesting question. And thank you guys for listening, and have a good day.